All right, welcome back. We are live for the weekly, or I guess bi-weekly, this past 2 weeks,
Yeah, bi-weekly.
SKTLs monthly crypto or weekly crypto chat. Yeah, I'm all out of sorts. So we don't have Cody, we don't have Bryce. Things are just weird here, but to balance out that weirdness, Dan Geraci, CEO of Freedom
Yeah,
Fall Aerospace. How you doing?
good. More weirdness. Yeah, no,
Oh, okay. Well,
I'm good. Lots going on. Last week I wasn't able to be here because I was at the Satellite 2024 conference in Washington D.C., which is one of the two or three largest space industry conferences in the country. There were close to, people were saying, between 12 and 15,000 people. It sure felt like it. The National Space Symposium, which comes up in April in Colorado Springs, will probably be as big. It's usually larger, but this was an unusual turnout for the satellite conference. And so, what goes on at these things is everybody in the industry is there. Everybody from government, military, commercial, startups,
I
900
think
pound gorillas.
Skytles and perhaps the founder was briefly thinking about setting up a booth there. I think that would actually be great, like next year, if we
It
could
would be
arrange that.
interesting because, I mean, and believe me, you set up a booth at these things, it is not cheap.
Yeah.
But the notion of, um, a lot of these companies, being there who are working on debris. Um, there's quite a large contingent. What a lot of people do is they don't even set up, excuse me, they don't set up a booth per se, but they will hold court in certain places, and they'll set their stuff up. They'll find a table somewhere. It's pretty wild. A lot of people don't even go to the sessions, don't even pay for any of the sessions. They just want, the exhibit hall is where everything happens.
Mm.
And it's just nonstop business getting done up and down with hundreds and hundreds of companies there. So, but it was a good week, very productive week. Now the industry's all back trying to figure out, you know, how to get out from under what they came back to. But it's interesting. For today, I wanted to draw everybody's attention. I posted this article in the in the uh, in the thread, but the Voyager spacecraft, the original Voyager for anything space, before there was before there were TV shows, Star Trek Voyager, and before there was Voyager Space, a company. Um, it is now all about the 47-year-old spacecraft that is still operating. And I think this bears mention because it's just a remarkable feat of engineering. It was launched in 1977. And I mean, for those of you that were alive,
I just
um,
came to be in
yeah,
77.
you just came to be. So you were both hatched
Yeah.
at the same
So actually,
time.
this I was late, so this thing was probably even older than I am. So there you go.
But the interesting thing is there were some anomalies with this in the past. I know the Planetary Society, we worked on fixing some of these, but at the end of the day, this thing is 24 billion kilometers, or just under 15 billion miles away. Um, so it seems like it's really far. Gee, it must be out of the solar system. Well, not exactly. So the edge of our solar system is defined as the outer edge of the Oort cloud, OORT, which is the giant cloud of comets that surrounds our solar system. And that's considered the outer edge of our solar system. It will take another 300 years for Voyager to get there, just to give you an idea
Oh, yeah.
of the scale of what we're talking about. Interesting thing. Um, we talk about signals reaching Earth. This is another good way. A signal being sent at the speed of light from that spacecraft takes 22 and a half hours. I had to make a note of that. 22 hours and 34 minutes for the signal to reach Earth. So, this is the extreme. We talk about Mars being an 8-minute lag, say, oh my goodness, gee, they have to do everything without waiting for answers. Well,
Hmm.
robotic spacecraft, it's a thing. And the fact that this has lasted umpteen times longer than it was ever designed to, and it's still, this software problem was causing it to send in unintelligible data. And so they think they've got a way to fix it now, by nudging it and doing a few things to get it straightened out. And it'll continue to perform. But it's truly amazing when you think about something that has gone that far, um, built, which is really 60s, late 60s technology for something to fly 10 years later. Most of the technology is 5 to 10 years old. So this is Apollo era technology. Um, and, we were doing good stuff back then. And that was the Jet Propulsion Lab in Pasadena. Um, so I bring that up because for those who want a little bit of nostalgia and a reminder of, we've been good at this stuff for a long time, and that's not changing. So I just thought I'd mention that. Do you want
When you
any
talk
up?
solar system terms, I am familiar because that was like my favorite subject back in the
Yeah.
school days until I got to college, and then I took astronomy, which I had no idea how much math would be involved.
Oh,
I mean, the cool part is, looking at all the stuff and understanding,
right.
why, things are the way they are and
Yes.
the way stars travel and stuff. But all the calculations and stuff, I was just like, man, that I got out of like the very first class I signed up for at college was statistics, and that way I could get my one math out of the way and done. Because once they brought letters into math, I was just, I can't do this anymore.
I love
So,
it. I love it.
uh,
Yeah, astronomy's great. Um, but when you start to get into the science, I mean, everybody should get a young person in their life a telescope.
oh
You'll
yeah.
never you'll never spend better time with a kid than
Yeah.
outside, under the stars.
And that was the coolest part of that college course is the guy had a, I guess, mini, uh, was it observatory,
Yeah, yeah, yeah.
and he had, farmland up on the mountain, and it was a beautiful spot.
Oh,
And I brought my buddy with me, and he like popped his head in there, and he had never seen Saturn before, and he was just like, "Holy!" And it was like just the greatest reaction because it was awesome. You
yeah.
see, and with a good telescope, I mean, you could see like the
Oh,
moons around Jupiter and things like that. Like
with a good pair of binoculars, you
yeah,
can see the moons around Jupiter
oh yeah, fair,
and
yeah,
Saturn. I mean, depending on how clear it is, but I always get a kick out of being somewhere where it's dark at night and you're with people, you're out or whatever, and you say, "Hey, look at that! You know what that is?" And then if there's
like the
binoculars
galaxy.
around, they just go, "Whoa, yeah." Well, if it's a really good night, you can see
Yeah,
some pretty interesting little galaxies,
yeah,
if you know
the
where to look,
coast,
especially in
and the
Orion.
yeah, the coast in the Mid Atlantic. There's a couple photographers that go out and do, I
Yeah,
guess, the long exposure, and it's beautiful because it's on the coast. There's pretty much no lights where they go because they go to these
gorgeous.
like state parks, and
Yeah,
yeah, you can see because of all the light pollution, it's right above us, but you can never see it. And then they do these long
yeah.
exposures. It's just like, oh my gosh, it's right there. That's
Well,
so
that's
cool.
why I'm happy to be living in Arizona now
Yeah.
because we've got some night skies that are just ridiculous. So I'm looking forward to getting out away from. You don't have to go far
Mm-mm.
around here to find darkness in the desert. So
Oh yeah.
it's a pretty cool thing. But yeah, we've gotten away, unfortunately, at the professional level from. Um, Optical astronomy, from looking through telescopes. Most astronomers, around the world are sitting at a computer using a telescope halfway around the world on top of some mountain someplace because they have viewing time allocated to their institution. And that's how it gets done.
And
Standing under one of those giant telescopes is a pretty wild thing.
Yeah. And to be
in an
fair,
observatory.
I'm definitely a fan of all those who do the math because if
Sure.
they detect something that could slam into our planet or something like that, then that I mean, these guys are doing math on things that they
Oh
can't
yeah.
see or trying to explain why they're, something should be there that they haven't detected yet or something like that.
Oh yeah. And they'll
It's
compare
wild the stuff that
images and
they
they'll
do.
say, okay, this was here in this image. It wasn't here in this image. Okay.
Yeah.
Or this appeared in this image that wasn't there in a prior image. But the math component of all this is so rigorous in terms of being able to predict, and it's all orbital mechanics and all of these calculations that allow us to launch something and land it on a little rock after flying, billions of miles and, taking a scenic route to get there, and we nail it. People don't understand how complicated that is when you're working in the limitless dimensions of space, and I think that's something that there isn't as much appreciation for. But when you look at a lot of these observatories and a lot of the work that's being done, it is around Earth defense, and it doesn't get as much airtime as it should. We had one little scare several years back when Apophis was discovered, the asteroid that came very close. That's coming back in 28 or 29. That's
I think
supposed to
it's
be with it.
29. Is that the
Yeah,
major one? Yeah.
yeah, and that's
Okay.
kind of like on a. I think it's a Friday the 13th of
There we
April.
go.
And like let's really make this amazing, and it will fly between the Earth and the Moon. So in space terms, that is flipping close.
Right.
I mean,
Yeah.
that is like me. And so um, this whole issue of Earth defense is a big one because we're worried about debris, and that's fine. We get a rock of any consequence that hits the planet, and it's going to get pretty. People forget about anything off the surface of the planet for a while because
Yep.
it can be pretty devastating. And they don't have to be big. We've all seen the stuff, and gee, this one was only 15 feet across, and I mean, look at Meteor Crater here in Arizona. That was not a big rock that caused that hole. So I think we have to do a better job. We're doing a better job of looking further out and tracking things as they come in. There was one that went through the solar system and exited, which was believed to be the first interstellar visitor that
Huh.
wasn't from our solar system, called Oumuamua, which came in I think it was 2017. Now, God, was it that long
It's
ago?
like from the Hawaiian galaxy or something.
Oh, yeah, it's
Yeah.
the visitor from, because I think it was University of Hawaii, one of the telescopes there that
Right.
discovered it. But it was this very oblong, very long and thin, and it was moving at a ridiculous speed. And it actually made a very interesting turn around the sun to head out, which didn't seem natural. And to the so much so that one of the top professors of astronomy and astrophysics at Harvard came out and said,
That was a
this
Silver
may
Surfer.
this may be, intelligently directed. And that caused a big kerfluffle everywhere. What are you saying? Because this notion of taking asteroids, and one of the very common strategies for the future of building spacecraft is you take an asteroid and you put your mining facilities, production facilities on that asteroid like we would anyway, and you start producing everything, but you build the spacecraft into the asteroid. So it's part spacecraft and part rock. You're already on a trajectory.
Right.
And that's what he was positing, that this thing could have been something artificial.
Huh.
And it turns out it was the second interstellar rock that flew through. There was one years before that never got reported on, that was found um, in military records for tracking spaceborne stuff. and there
And
was
they would
another
just know that by the
the trajectory,
trajectory.
the
Okay.
trajectory, the speed. It's the way it's moving through the solar system. What plane is it on? Is it following the the ecliptic the plane that all the planets are in? Is it
Mhm.
following that, or is it at an angle? This was at a steep angle, because a lot of the risk we worry about are things coming perpendicular to the solar system, not straight
Yeah,
on,
we're
where
not
we
all
can
on
look
one
out
plane.
and
There's
see.
things up and down, and
Yeah, so
yeah.
we could get something that's coming up, and that was one of the theories about, you know, there's been for many years, there's been a theory about there's another planet, but there's another planet in our solar system that's so far out and has such a long orbit that it might orbit the sun every 2 or 3 thousand years,
Ah,
that type of thing. And there was a lot of talk that it's at this very inclined or perpendicular type of an orbit to the sun. Um, so all these things are interesting because no one's been around long enough to test them with current technology. So
right.
the old story still kind of get some legs, um, with this. But Earth defense is going to be something you'll hear more about. Planetary Society, we do a lot about that. We talk to Congress about this all the time. There was a point where they stopped the funding. NASA stopped funding near Earth object, NEO, as we call it, near Earth object research. The Planetary Society gives out grants because most of these are discovered by amateur astronomers who have a really cool setup at home, and they get out there at night and they're photographing certain sections of the sky, and they're looking for anomalies. Hey, this showed up, it wasn't there 2 days ago, or it was here 2 days ago and it's here now, and it's here now, and it's so this is how they find them. I mean, it's painstaking work. It's not like they have red and green lights flashing on them. They say, "Hey, here I am."
Yeah.
You know,
Are there other countries that do this and support this, or is it kind of just like their private amateur citizens like come to
oh,
the government and be like, "Hey, I saw
it's the
this."
same thing. I mean,
Yeah.
it's interesting. I mean, they have to rely on that, especially in countries that don't have the infrastructure. Even
Yeah.
China, there are thousands and thousands of local little groups that are into different things. I was reading an article on this, but where they are encouraged to report stuff they see because they've got billions of eyes
Oh yeah.
everywhere. So and one of the things, it's ironic, but there are more groups in China that are focused on reporting and tracking UFOs than for pretty much anything else. And that's how China deals with that, is they have all these citizen groups that are encouraged to just post stuff because they
That's
have no
funny.
other way to collect information.
Yeah.
So citizenry, no matter what the purpose, can be really helpful in
So that
filling
kind
in
of sharing
gaps.
is encouraged over there. Go figure. But
Yes,
yeah.
yes. Because of course, we're going to find out that you know the aliens are their buddies, and of course we're all in trouble. That's what they
Yeah.
like us to say. Yeah.
Yeah.
Anyway,
Just like it was scripted.
that's right. So there's in Europe. There's a lot of research going on. Universities tend to try to do this, but you need big deep space communications and observation capabilities, deep space networks, things like this. Now you start getting into pretty much US territory, if you will, in terms of technology. You know, the other big players aren't sharing anything, so you're not going to see anything coming out of Russia. You're not going to see anything coming out of China. Japan's very involved. They're really good partners on this. ESA, the European Space Agency as well. So, um, but it's the biggest risk because we know they happen.
Well,
When
talking
we don't.
about okay. I was gonna say talking about, I guess, different pieces of equipment in space. That just brought to mind a question. So, if Elon's main mission is to get to Mars,
Mhm.
whether it be decades from now or whatever that is, would there be ideally like bus stops along the way, like stations, because I mean, it's just a straight shot. It takes what, months and months. So, I mean,
Depends.
would that even make sense, or is that like in the thought process, or is it just a straight shot there, straight shot
Straight
back?
straight shot there.
Yeah.
And what remains to be seen is, because everything's designed now as a straight shot. Take everything you need, your fuel and
Yeah.
everything with you. By the time we get there, a couple things could happen. One of them will be what we're using for fuel, because there's a lot of work being done on nuclear propulsion right now. And if nuclear electric or nuclear thermal propulsion can be harnessed properly, then we're talking about um, far less time to get there. It could be a couple months, depending on what we have and how fast we want to push it.
Yeah.
But we could get there much faster, which changes the dynamics once again. Space flight. Suddenly now you don't. It's not you know an 8-month trip out, and then you have to spend a year on the surface so that you're back in the same alignment between the two planets to make the shortest trip possible back for 8 months. So it's a 2-year, 3-year mission, which is daunting because you have to bring everything you're going to need to survive with you. No one's going to come out and rescue you or help you or fix something.
Yeah.
So now that we've got better propulsion coming on stream, we have better rockets, we're shrinking the transit time, which de-risks the mission because less bad stuff can happen in a year than can
Yeah.
happen in 3 years, right? And then in terms of going back and forth, the only thing I could see being there if we were still using conventional fuel will be, there may be some fuel depots anyway, but they're going to be around the moon. They may be at the Lagrange point, so a little further out. And then they'll be in orbit around Mars at one point as well. But pushing that hardware all the way out is very expensive. Just like it's super expensive to go beyond LEO, beyond low Earth orbit. It gets more expensive the higher up you want to put your hardware. So, um, and it's not just fuel, it's all the mechanics we were talking about of moving around in space.
Mhm.
So, it'll be a straight shot. The wild card is how fast are we going to get there? And, but I think, Elon will get there, I think, ahead of any government.
Oh, yeah. I would
Not,
put
I mean,
that would be my bet right
I
now.
could see, China, throwing something at Mars and saying we got there
We got
first.
there.
And I that there is going to be a lot of there are going to be some failures. I'd be shocked if there weren't. We should expect it. I was on a panel last night, the Arizona Tech Council, and we are talking about the future of space, the space economy just here in Arizona, but we were talking about risk in this risk culture that's grown up around rockets that NASA and the media, perpetuated in the 60s and 70s, where failure is not an option. And, if something goes wrong, it's the end of the world. Elon's erasing that from our memory as quickly as he can by saying, so we blow stuff up and we start over. The point I was making last evening was the difference is when there are lives
Yeah.
involved, then it's a whole other ballgame. And I encouraged people to go back, and I would to anyone who's with us today, but I think it's the Science Channel, or I'm pretty sure it's not History. It's pretty sure it's the Science Channel. But go looking for the Lost Apollo films. They found a bunch of films in the archives at NASA that were stuck on a shelf because back in the 60s, believe it or not, for Apollo 11, they recorded over most of the videotape of that mission because they needed the they needed the tape,
Mm.
believe it or not. But they have found a lot of the old original film, thank God. But pay attention to what happened, with all those rockets blowing up in the early years of the program. But then the Apollo 1 pad fire, where we lost Chafee, Grissom, and White on the pad during that test, that almost shut the program down. The shuttle disasters almost shut the program down. It takes strong leadership to say, hey, we're going to just keep going and we're not going to quit, because there was a lot of people that wanted to bring an end to it um, when Challenger exploded, and Reagan right away, hell no, we're building another one and we're going to keep going. And
I guess we have technology nowadays. I mean, even though it still takes time to diagnose such issues, I guess, it's gotten easier to do that, because pretty much all you had, I guess, maybe you had some sort of detection devices on older ships, but you had video, like with the Challenger thing, because you could see, the ring coming apart, or,
right.
One of the tiles coming apart. And that was kind of like, oh, well, that confirms it. But if we didn't have that, who knows?
Oh, yeah. Yeah. I mean, the space program has given us so much technology and so much capability. And the naysayers choose not to. Oh, well, we would have figured that out anyway. Yeah, okay, sure. Um, People who just don't think it's worth it, and and yet they're worried about the planet. They should be worried about the species on the planet, because that's what this is all about. And so, we'll learn a lot more about our own planet by going out there. That's why we study other planets. That's why planetary science is a massive part of NASA's mission and these robotic missions. What we're learning about Mars is going to teach us a lot about what could happen here, because that was a water world. It's obvious there's a ton of water. There's water under the surface now, that we know that. We've seen all the evidence of it. Was there life? Who knows? But it was a wet and likely green planet. And so, it had all the ingredients. What happened? The atmosphere burned off. Its rotation is wonky. It's got some bad scars from some heaving. It's still active. There's still water flowing under the surface. We still see it bubbling up. We still see that there's volcanic activity. We know there's volcanic activity all over the solar system. Saturn's moons are burping constantly, and we can see the plumes. So, we need to know more about what's at risk here by studying other places, and that's the best way to. People want to justify, or justify not funding NASA. Earth observation is one of the biggest things we do now. And that happens from space. Last time I checked, not from here. So,
I mean, we can walk around and observe Earth right now.
Yeah.
Well, good stuff, man.
Yeah.
Well, I mean, we're already like at the bottom, past the bottom of the hour. It just seems like it just flew by.
Oh, yeah, I tell you.
But that was good stuff.
Yeah. Well,
I
glad
know
everybody can join us, those who did.
Markets, crypto, and mainly space debris related to the SKTLs cryptocurrency. But we also talked the latest news, and thankfully you're here to do that. And that was just a fun discussion, just selfishly speaking.
Yeah, no, it was. It was. I mean, hopefully Cody can join us again someday. So we'll see.
He might be watching. We'll see. Say hi to him in the chat. But
I bet he is. Yeah.
But until next time, I'm sure he'll catch the replay.
I'll probably get a bad text any minute now.
What do you say, Dad? All right. We will be back next week, same time, 4:00 Eastern on Wednesdays. That's when you can usually find us. And until then, we will say goodbye, everybody. See you then.
See you, everybody. Be safe.